following from what we discussed earlier, we said that we got to express the standard in some manner. So, one is physical terms, simply physical terms, measurable item, like the condition of the element specifying the magnitude of defects which will require remedial action. All right. Wherever possible, the extent of the defect should be capable of direct measurement, right, to ensure uniformity of interpretation where more than one person is responsible for inspection. As we shall see later on, a planned maintenance would invariably, I mean, it must, it's a inspection is a must for planned maintenance. So, you have yearly inspection every year before you do the budgeting. This inspection is a must. Anyway, coming back to, so you inspect also what is the state, whether next year you got to do the maintenance or not, you got to measure them or check them. So, you take your items and check wherever it is measurable, right. Now, I was just trying to let me see where one can measure examples. I have given you, of course, internal painting lux meter thing, but some other cases. Let me just recollect if there is anything which is measurable, and then put it into the like the inspector should measure. Which would require regular maintenance. All right. Even measuring, let us say, water pressure at certain level in the pipelines, especially in the later part of the life, if there is a if there is a leakage or something of that kind, or I mean this is not leakage, but gradual. I was trying to see if there is something example I can give for the gradual failure. Gradual failure, if there is something, some example, lighting I have given you, external painting I have given you. Some of the other items, of course, we know the periodicity from other consideration, but some places because structural system are not supposed to deteriorate, but supposing the deterioration is occurring, you see, or for example, visual moisture marks. I can go to a slightly advanced scenario which is normally at the moment not done. Supposing one very important building is there, let us say something like a laboratory, sort of a production unit of, let us say, Semiconductor Limited, which was producing, I do not know whether it still produces electronics chips or similar of an, it's a sophisticated one. Now, there the moisture condition, the dust condition, they are very specified. So, they use what is called a clean room. A clean room, the filters there for the air conditioning system, fresh air entrant is very high level filter. Do not allow particulate system above a big size, which is not related to breathing, but the system. Also, the rate of fresh air flow is much higher there. Similarly, relative humidity, there cannot be variation. So, and then it is all false ceiling, etc., to ensure that there is sufficient, sufficient two things. One is the look part of it, otherwise you want a gap, insulation, air conditioning, temperature is to be maintained. Now, suppose there is a moisture, issue of moisture could be there, leakages from tank or something of that kind. The best way to keep a survey every year is to do a infrared thermography, right. So, infrared thermography, the color changes. I mean, it is basically, what it does, it measures temperature. Infrared radiation is heat radiations are all infrared radiation, and the infrared thermography or videography even one can do, they are very sensitive to very small temperature difference. So, if you do that to the whole building, you can find out whether there is any patches where there is moisture, because where there is moisture evaporation occurring, temperature will be lower. So, from the color change one can find out. So, indicator of blue color or XYZ color, and if the area is more than so much, it calls for. So, you might quantify this. I have just given an extreme example. There are many other examples of the similar kind where it is measurable, right. So, that is one thing, right, that is one thing. So, where you can measure the quantity, there other example is of course structural scenario. I did not want to go into too much into structural scenario, but then this do happen. Supposing the moisture marks are there in a building, and you find that there possibly chance of reinforcement corrosion. So, whether the reinforcement corrosion is actually occurring or not, whether you need the maintenance or not, that you can find out from some electrochemical measurements like half cell potential measurement or something like looking at resistivity. Now, bridges also these are important actually. So, you might do from time to time see if there are any sudden changes are occurring in the values of the potential or not. So, I am just giving the extreme examples for measurable quantities. There are many more, right. So, wherever possible physical quantity measurement, and it is not, it should not be, it should be independent of persons, you, me, him or somebody, it should be independent of persons. So, that is what it is. So, direct measurement, and then you specify okay, the voltage, the half cell potential below minus 350 more negative than minus 350, actually there is a risk of corrosion is very high. So, you specify that if it is minus 350 or more sudden change, then that area you should open up and do maintenance or whatever it is. So, that kind of possibility is there. So, these are called condition controlled maintenance, right. This is called condition controlled maintenance, and its purpose is, there will be an inspection. It presupposes there is an inspection. Obviously, all planned maintenance systems should have an inspection at appropriate intervals in order to determine by visual means or measure whether or not the condition of the element of their performance has deteriorated below the laid down level. It can be simply the area, affected area quantified, measure the affected area, moisture marks, measure the affected area. If it is more than x percentage, maintenance is required. So, that is quantification, right. So, this is quantified. So, condition control. Then there is some which are periodically controlled from your past experience or the guarantee that has been given by the manufacturer or the people who have given you. For example, external painting sometime or internal painting, sometime the manufacturer or the paint manufacturer will tell you 7 years guarantee. So, you got to repaint it after 7 years. So, this is periodicity, sometimes referred to as frequency based maintenance. So, this is frequency based maintenance and certain knowledge of the rate of deterioration of the point of time, either functional failure. So, after that period there will be a functional failure, it may not work, or the appearance will become unacceptable. Now, painting fits into this very well. Functional means what? If it is external, it is supposed to drain out the water, no algal growth. So, after 7 years it may not be able to, after all those polymeric systems, silicone or whatever it is, they when they are exposed to very ultraviolet radiation or solar radiation of the complete thing, their characteristics starts changing. There are several things can happen under such situation, or moisture and rain, wind, etc. With time they polymerize given temperature and so on, maybe polymers characteristics change, some sort of changes. So, maybe the water repellent characteristics is lost after a certain period of time, and that is known to them, known to the manufacturer. They have told you okay, after 7 years the it will not be repelling the water. It is one of the functions is to keep the water away, so that water do not enter into the envelope, walling system or structural system. So, that function it may not be able to perform, failure after 7 years, or it might look ugly. It might look ugly, maybe it will start allow dirt accumulation to such a level that it does not look anymore nice. So, this is periodic time, where it is has been fixed based on periodicity, simply frequency based. So, clearly it has to have consequences of failure has to be seen. Now, certain things, for example, we will see that lamp replacement in lamp replacement in large areas. Factories very important, because lighting level is very important for your production system. So, if you do not maintain, if the like the light is not there, maybe the operative, the workforce is not able to perform, the work it may be stopped simply. Extreme case is supposing it's a factory where very fine items like watch is being produced. So, implication of not doing, it might be frequency based on the previous study already done on mortality curve of what is called lamp. We will discuss this mortality curve sometime, rate at which it fails. So, based on that you have decided a frequency, okay, I will do the maintenance replacement of all the lamps at a given time. But at how many percentage failure of how many percentage of lamp at which you will do actually complete replacement, that will depend upon, if you do not do, then what is the cost implication, indirect cost implication, because your production might stop. So, not all situations will be similar, situations of different functional buildings, different issues will be there. So, it has to be a balance between frequency and implication, cost implication. If it stops your production, if it stops something, then obviously you will be more bothered. If you do not do, some cases it could be, for example, the humidity not maintained in a textile factory or garment factory where fibers change their dimension, or somewhere some fibers change their dimension with relative humidity, the production system might get disturbed. So, these are the indirect implications. So, some cases condition, same item might be either condition, it is possible to put it in the condition based or frequency based, but you will have to decide how you want to handle. Then there is a third variety, finally the financial criteria, which could take indirect cost of not maintaining and direct cost of maintenance. More frequently I do, my cost of maintenance will increase, but if it has got a very strong repercussion on failure of the system, then obviously I have to take care of that. Say in a hotel, well, I got to do almost, in hotel for example, I got to do it at a war footing basis, because the financial issue is involved, my return, the occupancy level, it's depending upon that. So, some cases it would depend, it is basically some sort of a sum related to cost of some primary activity. So, primary activity in hotel is actually renting it out, right. So, if it affects that, replacement affects that, or some fixed sum based on historic costs, if I do not do, what will happen. So, basically economic analysis will dictate. Some items will be simply based on economics. I said that carpets change in hotel, nothing goes wrong, but then they do not want the same look, because people who come in, they have better feeling. So, just change, nothing has really gone wrong, no frequency based, just financial implications they say, and finally make it of course frequency based. So, this is how it would be done. So, this is the same diagram that we are talking about. Now, let us see out of this same diagram from that we followed. Now, out of this let us see which one, how do we go about it. But before doing that, we must also understand one thing, as I said, that financial criteria or frequency based or condition based, all of them, particularly the later two, depends upon at what level I want to provide its basic maintenance objective, related to basic maintenance objective. For example, if there is no financial implication, I do not need a good level. Say some factory or somebody is providing housing, say real estate business or whatever it is, providing housing for a group which cannot afford very high price. So, for them they will keep the standard also at the low level. Therefore, your frequencies etc., all will get related to that, right. Is the maintenance objective will be different. So, maintenance objective or your periodicity etc., everything depends upon the level. So, we must classify the level. So, we classify the level in 3 different levels. Levels of acceptability, limiting this to habitable or working areas of a building, it is possible to distinguish 3 broad levels. This is qualitative level. For example, a lowest level is that level where immediate it is not intermediate, it is actually immediate environment should not be directly harmful or uncomfortable. You are just merely managing hygienic condition and just comfortable condition. The example that I was giving, perhaps if you look at, there is something called tropical summer index, which is used for thermal comfort in Indian context, which is a function of relative humidity, temperature. I think I might have mentioned one day, temperature, relative humidity, air velocity, etc., etc. Now, its comfortable range is 25 to 30 degree, right. 30 is equivalent temperature unit, it is the same, but a tolerable range is 19 to 34. So, just comfortable range, I might like to even extend it to a little bit. At lowest level, okay, because they are unlikely to use air conditioner, and it may be almost impossible to provide in naturally conditioned building, not actively conditioned building, naturally conditioned building to maintain a temperature between 25 to 30 in a climate of, let us say, something like Delhi or even many other places, Chennai, etc., where it is the temperature is very high, relative humidity is also very high in Chennai, where Delhi some season it may not be possible. So, you say that okay, we will at least maintain up to 34 degree lowest level. So, this is the lowest level, it should be barely comfortable, not harmful, hygienic condition should be maintained, and it should be. So, this is the lowest level. Now, we come to middle level. Here you should be comfortable. Now, couple of days back, if you remember, in this classroom the air conditioning system was not there, and in fact the class that we were taking, almost everyone felt that when we should be going out, including myself, right. So, actually concentrating also becomes difficult, because it is otherwise meant for air conditioning system. So, therefore, there is no natural ventilation in that, and if supposing because of the season change we have not started the operation the very first day, we felt that, which means that our efficiency would go down. You might stop the class early and go away, everybody would, everybody is feeling uncomfortable. So, this is your performance level. So, minimize the effort and maximize the output. So, maintaining the level. So, therefore, if these classrooms, if they are there, therefore, you would like to say that since especially in modern kind of multi-story academic buildings, lecture theatres and such so on, because they are now closed from all sides, you have to maintain the condition where people are not uncomfortable. This is a middle level scenario. You have to have active system here. You cannot do without the active system, and it has to maintain it. While as I said, residential economically weaker section, you might not think in terms of that level. You might say okay, up to 34, because I am naturally conditioning it, it is fine, right. Similarly, lighting level, right, it has to be appropriate. If it is dark, then you may not be able to even teaching of reading will be difficult. So, this middle level would ensure that output is maximum. Even if it is residential scenario, generally that would depend upon the economic level of the people actually, but otherwise functional issues, functional building, of course, the output has to be maximized, and that is the middle level. Highest level is one where it should promote not only actual well-being, that means it shouldn't only maintain the comfort level, but you should also feel that it is actually very comfortable, feeling, or a pride, you take a pride into it. So, that is maybe a scenario of hotel, a 5-star hotel, where the pride is very important. So, somebody says, so no, it's not only is comfortable, I also feel that it's very comfortable, that kind of thing. So, psychological well-being or psychological feeling that it is better, simply not comfortable. So, this kind of levels of acceptability has to be decided. Then you can plan your periodicity. Then you can plan your periodicity. So, that is how we do it actually. Now, let us see how we do some periodicity, how we find out, how do we find out periodicity for some of the items at least, right. These are the levels, but some the examples I will take is, of course, they will not distinguish the level, they are general, some way how we find out. Now, how can we find out? One where I know the deterioration process, like I said, the slow deterioration process, I bring it back. Roof covering is one such example. If you had roof covering, it is not a year of, it is not a question of 2 years, 3 years, 5 years, all I am talking of in a time span of 60 years. So, 25 years might require for roof covering to show up its problem, right. So, roof covering, after how many years I should actually change the roof covering. Quite often we think that once we start constructed a building, everything, particularly systems like roof covering, envelope, structural system, you do day to day maintenance of what? Okay, there's suddenly the power has gone off because there's a circuit breaker which is not working, replace the MCB. This is the kind of maintenance one do. But civil maintenance, if you look at it, they do not show up so easily. So, first possibly roof covering leakage would start, couple of years later one would see a patch of moisture somewhere in the ceiling, and then few years later you might see chunk of concrete coming down because rebar has started rusting, reinforcement bar has started rusting. So, it's a slow process, we are talking in 25 yearly time or something of that kind. So, then there is a need to look into them and replace or maintain maintenance. This is generally, since there is very slow process, many of the civil works we do not consider. Something else we quickly repair is possibly a washer, tap washer. Tap, suddenly you go and open the tap and you find water is coming out like a waterfall, and you try to close the tap, it does not work because the washer has given away. Such as the examples. This would need possibly then immediate replacement. So, this is done, but then there can be a policy decision to change them in such a, we will see that how we do it. So, similarly there can be different types of item, how do we decide the periodicity, that is what we will look into next, right, how do we decide. So, first we take the case example of a roof covering, all right. So, roof covering you can see recycling or recycling of roof covering. So, we have something called first we define something called let me see if it is there here, not really, something we call it anticipated state matrix, right. Let me just first, in such situation what we do is we define something called anticipated state matrix. Certain items we do like this, where the deterioration process is relatively slow, and when deterioration reaches such a level, it is not economic to do the maintenance. So, we call it anticipated state matrix. Anticipated state matrix. Okay. Now, what is anticipated state matrix? We say define states, state number 1, no visible defect. Then 2, something like isolated. Now, in case of roof covering, roof tiles are there. If you see a roof, typical roof, depends upon which part of the country you are. In northern part you have a structural element, then you will have an insulation element, then you will have some tiles, waterproofing layer, and then some tiles, waterproofing at different level, and then you will have some roof covering tiles right at the top, some tiles should be there. And these tiles, supposing the moisture ingress has occurred, the tiles will start coming up what we call blistering. So, as if blisters have appeared, right. So, isolated blisters, Then the next stage, so states actually defined. Next stage, the extent also we might talk about. The tiles has gone away from the area, totals. Tiles have disappeared or something like that. So, these are anticipated states. Right. Some cases visible, the state could be that visible internal insulation, something of that kind. So, you define anticipated states as you are likely to see as once the roof has been constructed for there for many years. Now, this must come from past experience. So, you define anticipated state matrix, we call it. So, anticipated state we define. Then we talk in terms of after 5 years, how much area will you have no visible defect? How much area will have no visible defect? How much area will have no visible defect? Or it would be possibly 100% after 5 years. So, in each state after 5 years, how much percentage will be in isolated blister after 5 years? So, your one of the column would be or row would be 5 years, or actually column would be 5 years, then next is 10 years. Then in each stage how much area you see, area in each of the state after every year, which I will show you in the table, how much is there you can first, that is the anticipated state matrix. So, that is called anticipated state matrix. Anticipated state matrix will give you how much is a So, this is basically anticipated state, and this is the anticipated state matrix. So, 5 years, 10 years, 15 years, 20 years, 25 years. So, first state was no visible defect, say small isolated blisters, large blisters, slight cracking at the top you see, and then localized cracks, then extensive cracking and deterioration of causing widespread leaks, that is another state. So, these are the states that you talk about, and if there is no visible effect, remedial measures will be nil, cost involved will be nil, So, in a first table you decide what are the states, and then what is its implication in terms of repair, what action you got to take, and how much is the cost per unit area. Then you make the anticipated state matrix in which 1, 2, 3, 4. Now, you classify simply as 1, 2, 3, 4 states. So, you write states here 1, 2, 3, 4. After 5 years, generally you will find at least 80% in state 1, that means no visible defect. When we are talking of some 10, 20 buildings constructed together, which is the case, or larger area of a single building. So, you will find that 80-85% no defects, maybe 5% shows up, 5% shows up or 1% shows up some blistering, it can happen, and 19% shows small blisters. So, 1% shows some kind of defect. If you go to 10 years, no visible defect might be in 60% of the area, and 25% might show isolated blisters, 10% might show large, and so on and so forth. And this you will find that no visible defect goes on reducing with time, and this part which is extensive cracking, etc., this will go on increasing. Now, since you know the cost of no visible defect, you do not have to do anything. After 5 years, after 5 years, you will do a little bit of patch repair. 19% you will do a little bit of patch repair, and after 10 years also you might do patch repair. Now, point is, I will just discuss this and again talk about this in the next class. If you do patch repair, it is usually costly. Per unit area, it will be costly. Why? Because patch repair means the people who will do repair or the setup cost is high. Every time you do a patch repair, there is a setup involved. You will call the people, they will set up, possibly go there, reach there, set up some material producing unit if it is a cast in situ or whatever it is, and then they go and do a small area and go away. On the other hand, if you replace the whole thing, it turns out to be cheaper, because setup cost per unit area is only once, while in each patch repair you will require a setup cost every time, right. So, the cost would involve in a complete replacement of the whole area in one go, cost is usually less, because setup cost is only once, where setup cost is there every day. So, what happens is, if you calculate out the patch repair that you are doing, and if you do replacement, this comparison you can do. And when the patch repair cost, supposing you have got 50% area which is to be done patch repaired, it would obviously cost you more than, I am talking every 5 yearly, not one day, it will be over 5 yearly. So, patch repair cost will be higher. So, what you say, oh, forget it, you just replace the whole thing. So, you periodicity you have defined, that is the time I will do the complete replacement, You have to know the deterioration pattern and you have to have the data available.